Now, in the last video in this series, we dealt with equations involving one variable which is raised to a power greater than 1, in particular to the power of 2. And I said, for example, if we have this equation, x squared plus x is equal to 2, then the way to solve or find a solution for x is to get 0 on one side of the equals sign by subtracting, in this case, 2 from here. 2 minus 2 is 0, and then if we do that on this side of the equal sign, we have to do the same over here. So we have x squared plus x minus 2 is equal to 0. And then I said we should factorize, find two numbers which multiplied together give this expression, this number over here, and then we know that because they're multiplied together and equals 0, that one of them must be equal to 0, and we can generally find a solution or more than one solution for x if we do something like that. Now let's go back for the moment to algebraic equations which involve two variables, neither of which are raised to a power greater than 1. But let's consider the equation 4x, and it's an equation, by the way, because there's an equal sign in here. 4x plus 5, let's say, equals y. Now I said that there are a whole variety of solutions for that equation, values, that is to say, for x and y that make that expression 4x plus 5 equal to y come out true. And let's just write some of them down here. In fact, what I'm going to do is I'm going to change color to make it easy to see, and then I'm going to write out a table. I'll start the table in the same color. I'll put down values of x here, and then I'll put down values of y here. And let's find out what will happen for various values of x. Well, let's suppose first of all that x is 0. Well, what's y in that case? Well, it's 4 times 0, because x is 0, that's nothing, plus 5. So y in that case is equal to 5. 0 plus 5 equals y, that's to say 5 equals y. What about when x is 1? Well, in this case 4x is 4, plus 5, that is 9. So 9 equals y, so y is equal to 9. What about when x is equal to 2? Well, 4 2's are 8, plus 5 is 13. Y equals 13. So when x is 2, y is 13. What about when x is 3? I'll just do a couple more. 4 3's are 12, plus 5 is 17. Y is equal to 17. And I just cross my 7's there, and I'll just do one more. What about when x is equal to 4? Well, 4 times 4, 4 times x, where x is 4, is 16. Plus 5, 16 plus 5 is 21, is equal to y. So y is equal to 21. So now we have a series of solutions for this equation over here. Let me just say. And these are the solutions in this table. There is 0 and 5 is a solution, 1 and 9 is a solution, 2 and 13 is a solution, 3 and 17 is a solution, and 4 and 21 is a solution. Now suppose we wanted to find out what y would be for various values of x, for a whole variety of possible values of x, but we didn't want to go on working this out and writing a whole huge long list for every possible value of x. What about when x is 1.5, for example? Well, we'd have to work all that out, and it would get tedious to do this over and over again, all this working out. Well, there's another thing that we can do, and let me just change color to show you. We can draw what's called a graph. We can, we say, plot x and y on a graph. Now you probably remember what a two-dimensional graph looks like. It's got one axis going up there, and we'll start at 0. And it's got one axis going along there. Now this horizontal axis we generally call the x-axis. That's x, so let's just label that x. And this one going up, well, if that's the x-axis, what would we call this axis? Well, we call it the y-axis, so let's just label that there. And let's suppose that we have the following. On the y-axis, this is 0, and on the x-axis, this is also, right here, is 0. And now we want to go, let's suppose we want to go up to 10 with x. Let's suppose we've got 1, 2, 3. We should really do this on graph paper. I'm just drawing it rough hand. 4, 5, 6, 7, 8, 9, 10. So that's 10. That's 2, 3, 4, 5, 6, 7, 8. That's 8. That's 6. That's 4. And that's 2. And now what about for y? Well, I tell you what we'll do for y. Let's see what numbers we should put along here. How big or otherwise we should make this axis. The scale on this axis. We're going up to 10 here on x. What is y if x is 10? Let's just add 10 here. Well, 4 10s are 40 plus 5 is 45. 45 is equal to y. So if we're going up to 10 here on the x-axis, we should go up to 45 on the y-axis. Let's suppose that we do that. Now that would mean that, let's suppose that that is 45, and let's suppose that we go up in 5s. 5, 10, 15, 20, 25, 30, 35. Well, that looks like 40, and then we'll just go up here. And 45. So we've got 5, 10, 15, 20, 25, 30, and 35. Now, here's the secret of plotting, as we say, plotting the graph of x against y. First of all, let's go back up here. Let's take a look. X is 0, y is 5. So when x is 0, let's find it along this line here, this x-axis. X is 0 here. Then y is 5, which is here. So there, that's the point on the graph. X is 0 and y is 5. Those are the y's, remember. Okay, let's look at the next one. When x is 1, y is 9. Well, here's 1 here. Let's go up and find 9. Well, we've got 10 here. So we know that it's going to be just underneath that. And then we've got to go down to 1 here. Let's put a little x there where we think it might be roughly. It's going to be about there. That's 1 and 9 just underneath the 10. Okay, right, now what about when x is 2? Well, x is 2 here. These are the x's, remember, all along here. X is 2 here, and we've got to go up 13 along the y. Well, that's just underneath the 15, isn't it? So it's just about there. Whoops. See, it's much easier to do this on graph paper because you don't have to draw all these lines and get them all wiggly like I do when they're supposed to be straight, because my drawing is so terrible. So that's 2 and 13, which is there. 3 and 17. Well, 3, and let's go up to 17. That's just above 15 this time. It must be about there. And then 3 is there, so it's about there. And 4, likewise, let's go up. 4, it's just above the 20, which is just about here, thereabouts. And let's go right the way up to the 10, and that's 45, so we go up to the 10, and it's about 45 there. Now, something that you might notice, all these x's, if we filled in for for a half, where would the value of y be? Where would the point be? It would be just about there. If we found it for 1.5, it would be just about there. All these points lie on a straight line. Let me try and draw. Whoops. Try and draw a straight line through them. My straight lines are not very good. And we could keep on going up and up. And the good thing about drawing this line, this graph, is that we can just use it now to read off any value of y for any given value of x. For example, let's suppose we wanted to know what y is when x is 8. Well, we go along to the 8. Here's x is equal to 8 here, and then we just go up. Whoops, there we are. And then let's go across. So it is about... Whoops, that's not very good. So where are we? We're somewhere between 35 and 40. Now, if we did a really accurate graph and all these lines were straight and it was on graph paper and we did it properly, we'd be able to see exactly where that line would intersect, this horizontal would intersect the y-axis, and we'd be able to tell you what y is. We'd know then what y is for this value of x is equal to 8. From that graph here, what does the value look like? Well, it's a little bit above 35, not as far as 40. So it's somewhere between 35 and 40. It's a little bit less than halfway, isn't it? It looks like about 37. So we'd say that's about 37. And let's just check that. When x is 8, is y 37? Well, 4 8s, 2 8s are 16. 4 8s are 2 times 16, which is 32. 32 plus 5 is 37. Y is equal to 37. Presto, we got it right. So by drawing a graph like this, we can just read off these values without having to go through all of this working out. And that's a straight line, you'll notice, a straight line. And indeed we can continue it, I'm still in green here, but we could continue it back here, and we could continue these axes as we call them. These are the x values along here and the y values. We can continue them up and down into negative. So this is when x is 0. These are negative numbers. What happens when y is 0? Well, y is 0 here. Well, what's x? Well, it's about here. And that looks a little bit more than 1, not quite 2. In fact, if we work it out from this equation, it's minus negative 1 1/4. So this is the line based on these solutions for x and y. We call this, what do we call this line? We call this the graph, because this is a graph, we would write it normally on graph paper. Graph, gosh, my writing is just terrible. That's supposed to be graph, G-R-A-P-H. That spells graph by my reckoning. The graph of y is equal to, that's the y's up here, is equal to 4 times the number along here plus 5. Y equals, because when we write 4x plus 5 equals y, we could just as easily write y equals 4x plus 5, and that's what we normally do. Y equals 4x plus 5. Now, one of the things we find when we draw lots of graphs, I'm just making that of so you can read it, is that where we just have an x here not raised to any power other than 1, we always here, and we similarly with y equals, an x, there's only an x to the power of 1 over here, then we always along here get a straight line, a line. And so that sort of equation where we have a y, where one variable equals another variable plus bits and bobs, but not multiplied by itself, only to the power of 1 over here, we call that a linear graph, a linear equation rather. Linear, and it's linear because if you draw it out on the graph paper, it will give you a straight line.